Good morning, friends. Today we are going to take some glimpse of joint probability distribution. First, we are going to concentrate for discrete random variable because, as we know, joint probability distribution we can study for two concerns: one discrete random variable, and the other one is continuous random variable. Now, here first we'll concentrate on discrete random variable. Correct? Now, this table is called as joint probability distribution table or probability distribution table that we can take. So in columns, we used to take y1, y2, etc., yn. In rows, we are going to take x1, x2, etc., xm. This j11, j12, etc., j1n represents the position of the first row. Similarly, j21, j22, etc., j2n represent the second row's position. Like that, jmn, jm2, etc., jmn represent the last row. Okay, see f of x1, f of x2, etc., sum of these elements, first row elements, sum of the second row elements is f of x2. So like that, sum of the last row xm is f of xm. Like that, g of y1 is nothing but first column element sum, g of y2 second column sum. So like that, we used to take that. See, joint probability distribution says sum of these f of x1, f of x2, etc., f of xn should be 1. We have taken here, and sum of this also gfy1, gfy2, etc., gfym also 1. Then we can call this the joint probability density function. Okay, one important thing that we have to concentrate, note, two variables, discrete random variables x and y, said to be independent if this condition satisfied. F of xi into g of yj is equal to jij. Okay, if this satisfies, then I can say it is independent. Okay, when we take the problems, then it will be clear for us. Now these are all the formulas that we have to remember. Expectation of x is equal to summation xi f of xi for all I, and expectation of y is nothing but yj gyj for all j. Next, we used to take expectation of xy is xi yj jij, and covariance is nothing but e of xy minus ex ey, and sigma or rho xy is equal to covariance of xy divided by sigma x sigma y. Okay, these are the formulas that we have to remember. Now we'll take one example, then it will be clear for us how we can apply these formulas practically. Now here they had given joint probability distribution table, and they're asking us to get expectation of x, expectation of y, expectation of xy, sigma x, sigma y, covariance, and rho of xy. Okay, now first, to get all these things, the fundamental thing what we have to do is getting marginal distribution for both x and y. Correct? Now from this probability distribution table, how can we get marginal distribution for x? Simple. First, identify the x values. So in this table, x value is 1 and 5. See, I have taken that here, 1 and 5. Now corresponding value of 1 over here, how can you get that? See, add 1 by 8, 1 by 4, and 1 by 8. So what you are going to get if you add this, you are going to get 1 by 2. See, that's what we have taken here, 1 by 2. Corresponding value of 5 for x, what we have to do? We have to add 1 by 4, 1 by 8, and 1 by 8. If you add that, you are getting again 1 by 2. Correct? That we have taken here, 1 by 2. So x value 1, 5, corresponding value 1 by 2, 1 by 2. I can take this 1 as x1, I can take this 5 as x2. This is my f of x1, this is my f of x2. Correct? Now I can go to the marginal distribution for y. Okay, marginal distribution for y means what? If you go through the table here, see, y takes the value 4, 2 and 7. That's what I have taken here, minus 4, 2 and 7. Correct? Corresponding value of minus 4 is 3 by 8. How I got that? This 3 by 8 is the sum of the first column value. See, carefully observe here. This is the sum, 1 by 8 and 1 by 4. Okay, if you add these two value, you are going to get 3 by 8. Similarly, corresponding value of 2, what we have to do? 1 by 4 plus 1 by 8 I have to do. I'm going to get 3 by 8 again. Correct? And corresponding value of 7, I have to add these two value, 1 by 8 and 1 by 8, I'm going to get 2 by 8, that is 1 by 4. See, that's what we have taken here. Minus 4 is nothing but 3 by 8, minus 2 is nothing but 3 by 8, 7 is nothing but 1 by 4, 2 by 8 is nothing but 1 by 4. Now we have to calculate expectation. How we can get that expectation? See, without this formula, sir, I've forgotten the formula how to get that. Very simple. Once you get marginal distribution for x and y, getting remaining thing will be very easy. See, expectation of x is nothing but, come for this marginal distribution for x here. See, expectation is nothing but very simple. This 1 into 1 by 2. 1 into 1 by 2 plus 5 into 1 by 2. 1 into means x1 into f of x1 plus x2 into f of x2. If you do that, you're going to get expectation of x. Same thing we have done here. See, 1 by 2 plus 5 1 by 2. So if you simplify this, you're going to get 3. So expectation for x is 3. Correct? Now similarly, I want to find E of y, expectation for y. What is this expectation for y? It is very simple. From marginal distribution, you can go with minus 4 into 3 by 8, minus 2 into 3 by 8, 7 into 1 by 4. So if you do that and if you add these things, okay, so you are going to get 1. That will be the expectation for y. Correct? Simple. What we have done? We have done minus 4 into 3 by 8, minus 2 into 3 by 8, 7 into 1 by 4. If you add those things, you are going to get expectation for y. Now, we want to calculate expectation for xy together. See, it's very simple. You concentrate the first one here. Concentrate here. You just come for the table, the given table. So, expectation for both x and y is very simple. x1, 1 into minus 4 into 1 by 8. x1, y1, j1, 1. Okay, plus x1, y2, j1, 2. Plus x1, y3, j1, 3. Plus x2, y1, j2, 1. Plus x2, y2, j2, 2. Plus x3, y3, j2, 3. If you do that, see, that's what we have done here. If you do those things, see, this entire thing, we have done the same. What we have discussed, same thing we have done here. Okay. If you simplify that, you're going to get 3 by 2. That is my E of xy. Correct. Now, I want to get sigma x square. The formula is E x square minus E of x whole square. What is this E x square? Very simple. If you come to the expectation, see, E x square is nothing but 1 square into 1 by 2. Correct? 5 square into 1 by 2. That's what we have done here. See, 1 square is nothing but 1 itself. 1 by 2 plus 5 square is nothing but 25 into 1 by 2. So minus E of x already we calculated, that is 3. 3 square. So you're going to get 13 minus 9, that is 4. Similarly, we can calculate sigma y square. That is Ey square minus Ey whole square. So if you simplify, Ey square means what? Ey square is nothing but minus 4 whole square into 3 by 8 plus minus 2 whole square plus 3 into 3 by 8 plus 7 whole square into 1 by 4. If you do that, you are going to get E of y square minus E of y whole square. E of y is nothing but 1. 1 whole square is 1 itself. See, that's what we have done here. First, this entire thing we have taken minus 1 square. This is nothing but 79 by 4 minus 1. You're going to get 75 by 4. Now, covariance of xy is nothing but E of xy minus Ex Ey. Correct? So, E of xy we calculated. That's 3 by 2 minus E of x is nothing but 3 into 1 E of y. If you simplify that, you're going to get minus 3 by 2. That is my covariance of that particular problem. Correct? Now, rho of x comma y is nothing but covariance by sigma x sigma y. We calculated what is covariance, minus 3 by 2. We calculated what is sigma x, what is sigma y. So substitute those value, simplify, you are going to get minus 0.1932 or something. Correct? So this is the way that we have to do. So once we get the marginal distribution for x and y, it's easy for us to calculate E of x, E of y, Exy and covariance everything. Because E of x is nothing but what? x1 f of x1 plus x2 f of x2 plus x3 f of x3 plus etc. EY means what? Y1 g of y1, y2 g of y2, etc. Okay, up to n terms that you have to take. E of xy means what? In the original given probability distribution table, it is x1 y1 j11, x1 y2 j12, x1 y3 j13. So like that, for all possible combination, if you do, you're going to get exy. So exy you get, e of x you know, e of y you know, covariance you can easily write down e of xy minus exey. So it is very easy, even without remembering the problems. I mean formulas, you can easily do that thing. Now I'm going to take kind of different problem now. Joint probability distribution of the discrete random variable had been given, and they are asking us two things. One, find the probability of x plus y greater than 1. Okay, and show that xy are not independent, like that they're asking. Now here they had given y1 y2, they had given x1 x2 x3, correct? And this is j11 j12, this is j21 j22, j231 j32. So these things they had given. Now first part I'll come. See, I have written the same. J11 is 0.1, J12 is 0.2, J21 is 0.4, J22 is 0.2, J31 is 0.1, J32 is 0. So that's what we have taken. And now we have to calculate the probability of x plus y greater than 1. Means what? I have to first consider all possible value where it gives greater than 1 x plus y. See, when you this condition will satisfy, x plus y greater than 1 can satisfy it for these values. So this is possible when x is equal to 1, y is equal to 1. Because if you add these two, you are going to get 2 which is greater than 1. Likewise, it also satisfied for the value x is equal to 2 and y is equal to 0. Because 2 plus 0 gives 2 which is greater than 1. Correct? Also, this satisfied for the value x is equal to 2 and y is equal to 1. Because if you add these two, you're going to get 3 which is greater than 1. So, x plus y greater than 1, this value satisfied for 3 possibilities. For x is equal to 1, y is equal to 1. For x is equal to 2, y is equal to 0. For x is equal to 2, y is equal to 1. Now, I'm going to calculate for these things. Say x is equal to 1. Here, sorry, x is equal to 1 and y is equal to 1 means what? It is j22. Correct? See here, this table. X is equal to 1, y is equal to 1 gives what? For this, j22. Correct? That's what I've taken. X is equal to 2, y is equal to 0. X is equal to 2 means what? This one. It is x1, x2, 2. X is equal to 2 is this one. Y is equal to 0 means this one. Okay, means this value. What was the position? It is j31. So that's what I've taken here, j31. Similarly, you can take x is equal to 2, y is equal to 1. X is equal to 2, j is equal to 1 means this value. This is j32. That's what I've taken here, j32. Correct? So x plus 1 greater than 1 is nothing but j22 plus j31 plus j32. If you add up those values, whatever the thing you are going to get, that is p of x plus 1 greater than 1. Correct? Now this is what. Now I can go for to show the given variables x plus x and y are independent, not independent, that I have to show. See, in the first concept we have studied the condition of independentness. See, f of xi into g of yj, if it is equal to jij, then I can say two variables x and y are independent. If I succeed to prove this is not same, then I can say it is not independent. Now here I am getting one such example. Carefully observe, I am getting f of x1 and g of y1. f of x1, g of y1. f of x1 is nothing but 0.3. Okay, and g of y1 is nothing but 0.6. You may ask me, sir, how you got this f of x1? See, I'll come for here. F of x1 means what? First row sum. 0.1, 0.2. What you're going to get here? What you're going to get here? 0.3. Correct? This is my f of x1. Similarly, g of y1 is nothing but what? Sum of these values, column. Okay, this one, sorry, 0.1, 0.4, 0.1. So it is 0.5, 0.6. So I'm going to get 0.6. This is my g of y1. G of y1 is 0.6 and f of x1 is 0.3. See, that's what I'm doing here. F of x1 is nothing but 0.3. G of y1 is nothing but 0.6. If you take the product of these two, you're getting 0.18. And according to this one, it should be same as j11 because I have taken f of x1, g of y1, 1, 1. So it should be equal to j11. But j11 is what? What is j11 in the problem? It is 0.1. Correct. But what I am getting? 0.18. 0.18 is not same as 0.1. So therefore, f of x1 into g of y1 is not same as j11. So therefore, the given variables are not independent. Correct. So another example for the same. This is the joint probability distribution that they had given, and they're asking us to show that or whether the variables x and y are independent or not. Say independent means what? F of xi into g of yj should be equal to jij. Now all possibilities I'm calculating here. See, if you add these three value, whatever the thing you are getting, it is g of y1. This is g of y2. This is g of y3. Now if you add the rows, first value, this and this, whatever the thing you are getting, that is f of x1. This is f of x2. This is f of x3. Now I am getting the things there. This is the formula, f of xi into g of yj is equal to jij. Now first I will calculate f of x1, g of y1. That is 1 by 3 into 1 by 3. This is f of x1 1 by 3, g of y1 1 by 3. Both 1 by 3's are there. So it will be 1 by 9. It is nothing but j11. See here, j11 is 1 by 9. So like that, I'll calculate f of x2, that is 1 by 2 into this one, 1 by 3. Okay, so that you are going to get 1 by 6, that is j12. So like that you calculate f of x1, y of 3, g of y3, it will be j13. In the similar way, f of x2, g of y1 is same as j12. F of x2, g of y2 is 1 by 4, which is same as j22. F of x2 into g of y3 is 1 by 12, it is same as j23. Likewise, f of x3, g of y1 is 1 by 18, which is same as j13. In the same way, f of x3, g of y2 is same as j32. F of x3, g of y3 is same as j33. So therefore, here for all values of I and j, f of xi into g of yj is same as jij. So therefore, here in this particular problem, the given discrete random variables x and y are independent. Correct? Now, see, that's what we have taken here. F of xi yj is equal to jij for all ij. Therefore, x and y are independent. Now, I'll wind up this video for now. In the next short video, we are going to study the continuous random variable discrete probability distribution. Okay, we are going to study the discrete probability distribution and continuous probability distribution. So discrete probability distribution we have completed now. In the next session, we'll go for continuous probability distribution. Okay, thank you.